How do we measure glacier? Well, in the old days, we used to take a tough guy and we send him in the field. Some of his instruments usually freeze up because of the weather. And sometimes going back home can be really tedious. And you collect a few measurement points. And I remember my colleague and mentor, Bob Thomas, used to tell me when he was doing field work in the 60s, they didn't even know where the glaciers were. Well, nowadays, we take a computer scientist who just fall off bed and didn't have time to use his airbrush in the morning. And give him a bunch of satellite data and tell him you're going to map this part of Antarctica, which is bigger than California, and make a measurement point every 50 meters with a few % precision. And maybe we'll give you a nice pay raise in a few years. Everything is changing because of satellites. And satellites came about to study the polar regions in the 90s, so it's not that old. And none of these things were envisioned to be possible, even when the satellites were launched. It doesn't show us up as nice as on the screen. This is a picture of the Erebus floating ice tongue in Antarctica from Aster imagery. This imagery is, I mean, you have such high resolution imagery these days, you almost feel like you're there. If you were flying on an airplane over this area, it wouldn't look so much different. Okay, so there's 3 different ways. With these satellites, we study how the ice sheets are growing and shrinking with time. One is to measure the surface height of the ice sheet. It's like measuring if your son is growing or shrinking, you're going to measure his height every month. And this is done with radar altimetry. Over here, this is done with laser altimetry, which is more precise. With laser, you can measure the surface within 10 centimeters, with a radar within a meter. And this is also done from space. This is done from airborne in Greenland, and this is also done with ISAT from space. And you need to wait a long time because, as I told you, the accumulation on the ice sheet is only a few centimeters, 15 centimeters. So you're not going to get any result in 1 year. You're going to have to wait 10 years, even more, because snowfall is changing with time. It's doing some erratic things. But we now have some results because this data have been collected for about 10, 15 years now. The difficulty of this technique, however, is that you measure the height of the surface, which is the height of the snow, and this is changing with time, and you don't know if this is due to a change in snowfall or if it's due to a shrinking or a thickening of the ice. Now, the snow has a density of 0.3, and the ice has a density of 0.9. There's a big difference. So if you want to convert those volume changes into mass, it's really difficult. The other thing is the results in Greenland showed very early on in the mid-90s that the ice sheet was pretty much in balance in the interior. Most of the action was along the coast. It was thinning along the coast. And thinning was most pronounced along areas occupied by outlet glaciers, where ice is flowing fast. That's where also we see the ice thinning most rapidly. So this technique is a good indicator of changes that are taking place, but it's not good for mass balance assessment, even though a lot of numbers have been published using these techniques. Another technique came about, GRACE, launched in 2002. It's the only remote sensing instrument that doesn't use photons. It's measuring gravity, but the neatness of this technique is that because it measures the changes in gravity field of the Earth, it measures mass, right? Mass, the distribution of mass influences the gravity field of the Earth. It doesn't do that at very high resolution, but it doesn't matter if you're looking at snow or ice, a fast-moving glacier, or the vast interior of the ice sheet. You're going to measure the changes in mass of this area. And this has led to some very nice results in Greenland. This is the the shape of the change in mass of the Antarctic ice sheet from Veliconia and Ward. Veliconia, Isabella is sitting right here. She did this work with John Ward a few years ago. This was the first time we had a picture of what the evolution of the mass in the Antarctic ice sheet looks like. You see this blob here? This is an area of very rapid change in mass. The ice sheet is losing mass very rapidly in this area, and you see also another area here in the peninsula which is losing mass. It shows in purple. In Greenland, we have a lot of mass loss along the east coast in the south, and it's propagating also in the northwest.